So let's get into the action with our first section, that is structured data essentials, or in another way we can say exploring the elements of structured data. So data comes from many sources, such as if it is an automobile company or it could be a manufacturing company, whatever it may be. Sensor measurements is primary, then events, text, WhatsApp text, or it could be any social media text or mail or anything else, or any articles, word files, it could be anything. Then images, it's heavily used these days for a lot of application, from autonomous to the even just a simple face detection or mask detection. And videos, obviously, for the same. So this is what the reason the Internet of Things, IoT, is spewing out streams of information. Much of this data is unstructured. Images are a collection of pixels, with each pixel containing RGB. That's nothing but red, R for red, G for green, B for blue color information. Texts are sequences of words and non-word characters, often organized by sections, subsections, and so on. So click streams are sequences of actions by a user interacting with an app or a web page. In fact, a major challenge of data science is to harness this torrent of raw data into actionable information. So, to apply the statistical concepts that I presented to you in this course, the unstructured raw data must be processed and manipulated into a structured form. One of the commonest forms of structured data is a table with rows and columns. Everybody might have used it so many times in their daily life. Maybe it starts in our pre-secondary school. From there, we used to work on tables, which consists of rows and columns. So this is the most commonest forms of structured data that we are using, and as data might emerge from a relational database or be collected for a study. It could be emerged from a relational database or be collected for a study. So now let's delve into the structured data types. What are the basic types of structured data? Or I can say that as a, let's demystify structured data and understand the key elements of it. There are two basic types of structured data. One is numeric, and other one is categorical. Numeric data comes in again two forms. One is continuous, such as wind speed or time duration, and the second one we have is discrete, such as the count of the occurrence of an event. And on other side, what we have here is categorical. Categorical data takes only a fixed set of values such as a type of TV screen. What are the type of TV screens that you know? A plasma, LCD, LED, etc. Or different while sectioning your customers, so you will have either uh, uh, from 10 to 20 years age bracket, and 20 to 40 years age bracket, or 40 to 60 years age bracket. So like that you can uh, do that. You can do the marketing analytics or market analytics. And similarly you can categorize the automobiles. You can categorize the uh, types of industries that are available. So there are n number of examples for this categorical data. Or either you can go for the state names such as Karnataka, Andhra Pradesh, Tamil Nadu, or Uttar Pradesh, Haryana, and then Madhya Pradesh, Maharashtra, whatever it could be. There are even the students. Engineering branches is also a categorical variable. Mechanical, automobile, aeronautics, artificial intelligence, and computer science, ECE, triple E, all comes under again a categorical variable. So out of this, we have two types again. The categorical can be further subdivided into two types. The first one is binary data. Binary data is an important special case of categorical data that takes on only one of two values, such as 0 or 1, yes or no, true or false. So this is called a categorical variable. What is the example? Gender, male or female. And what's the another example? Have you liked this product? Yes or no? True or false? And is your weight 80 kg? True or false? So there are huge number of applications that we can find out for this binary categorical variable. Okay, this is binaries. And another useful type of categorical data is ordinal data. Ordinal data in which the categories are ordered. An example of this numerical rating example is the best example is a numerical rating for the ordinal data. It's 1 comma 2 comma 3 comma 4 comma or 5. So that's what. Or you can ask for the rate between 1 3 5. You have a specific order. It's ordinal. Okay. Everything has certain weight. So or you can go for the rating such as very good, or very bad, or moderate. Or you can go to the 5 levels of rating: low, very low, medium, high, very high. These are all ordinal types of categorical variable, or ordinal types of numerical. If it is depends upon whether it could be a numerical rating or it could be a textual rating. It depends. So why do we bother with a taxonomy of data types? It turns out that for the purposes of data analysis and predictive modeling, the data type is important to help determine the type of visual display. So, data analysis or statistical model. In fact, data science software, let's take Python, that's widely used, and I'm going to use the same. If you go back the time, people mostly used R for the exploratory data analysis, because it's specifically made for the data analysis. So either it could be R or Python uses these data types to improve computational performance. So more important, the data type for a variable determines how software will handle computations for that variable.